Welcome to the first Trademaid GSB video showing the initial walk forward optimizer that's been built in. The great thing about walk forward optimizing the system is it gives you a great deal more idea if the entry technique or the system is valid, and that can all be done with the enhanced walk forward optimizer, but it's fairly time consuming from a human time perspective and CPU time. So this is going to take a lot of the work out of the system process making, and as time goes on, more and more of this is going to be automated. So I'm going to just run the default parameters for S&P 500, 40% in sample and 60% out of sample. And I'll just hit start, and shortly a number of systems will start coming up. What I'm looking for is the most linear system, among other things, but that's probably my main criteria, something that just consistently makes money. So if I double click on RF here, which is Pearson's correlation, you can see that I've got a 0.994 Pearson's correlation over the entire equity curve. So that would be a good system to walk forward. As an example, something with higher metrics would be good, but I'll be quite happy with that for now. So I will stop the walk forward optimizing because the initial beta version of this is quite RAM hungry and we don't have RAM to do optimizing and building systems. So if I click on this section here, anywhere on that top line, and right click, you'll see that run walk forward is grayed out. But if I go to the leftmost here and click, you can see where my mouse is, and then do run walk forward, it will then begin the walk forward process. You can run multiple walk forward processes at the same time, but just keep in mind the early versions of GSB with walk forward are RAM hungry, so it's probably best just to stick with one. So in a couple of minutes we'll have done 10,000 walk forward tests. There's two ways to do a walk forward test at the moment. We can use the nearest parameters within a 10% value of what the current value. So if there's a parameter of 100, you'll try 110 and you'll try 90, and parameters either side of that in 10% intervals. Or the other option is we could use random variables here, and it will just try random numbers instead. It'll be quite interesting to see the difference in the results. We're only using 10,000 possible combinations, which is probably not many considering there's 2 billion variable combinations if we optimize every variable plus 4 variables and then down 4 or 5. But at least this will give us a sneak to see whether the system and the entry technique is valid. And that's the main purpose of this walk forward, just to validate the entry technique. As the product matures, it'll walk forward the entire process, including any additional filters that we put on there. You can see here that GSP has used 18 gig of RAM, and that's used up the RAM of the system that it's on. So I'm probably going to have to restart this again from scratch, and instead of using 10,000 tests, I'll use 5,000 tests. The next 2 builds away, which will probably be a week of GSB, will have that RAM issue fixed up. Now, because I've started to run out of RAM, I've restarted the app and I'm going to run this again. I've set multi-threading to false, so it'll use a single CPU core, and I'm just going to see if that will actually improve the RAM situation. So far so good, and it looks like single-threaded walk forward optimizing still looks fast enough. It looks like it's using a lot less RAM. So we'll let that run for a few minutes and we'll see what the walk forward curve looks like. I'm expecting the initial curve and the walk forward in sample curve and the walk forward out of sample curve after the result of this walk forward. On single threaded, it just made it as far as not using up too much RAM on a 32 gig machine. Next build, that RAM hunger should be fixed. But you can see the original equity curve is the browny greeny curve there for training and test, and you can see that the in-sample curve is the yellow curve on the top, and the light grey curve beneath there is the walk forward result. So we are really happy with this, and the fact that the system has now performed better after it's optimized, and the out of sample curve is almost as good as the in sample curve. So that's been a very successful test. I'm now going to go to the worst possible system I can find. I may have to change a filter here. Right, so I'm going to get a really bad system, and I'm going to walk forward test this, and I'm going to see how I go. To save a little bit of RAM, because I'm in the limits of how much I can do on this machine, I'm going to go to 7000, and I'll put multi-threading on, which will speed it up a bit. So I'll go here, right click, and I'll do run walk forward. And it'll be very interesting to see on a system that I'm expecting to fail what those curves are going to look like. So we can see here the walk forward has completed to 82%, and if I look at my RAM, it's using 11 gig of RAM, so that would be probably doable on a 16 gig machine. But as I said, give us a day or two and we should have the new build that, oh, that's completed, and now the RAM's gone down. So you can see the walk forward test, it's pretty ordinary, just as I expected. So not a system we'd want to trade. Note also how the gap between the yellow, which is the in sample, and the out of sample, the grey, is significantly further apart than in the previous test, which is one that I expected would work well. Thanks for watching the video, and in the next few days we'll be having numerous new builds of this come out, I'd expect.